Hello everyone. For today's demonstration, I would like to share with you how I can use Bluetooth to control two robots at the same time. So we're using two BT-210 and using Python, and I'm using the PySerial module on it. So there are two robots. I would like to be able to use up, down, left, right maneuver for it, and also I want to be able to read from sensor coming from the robot back to the PC. So the two robots are the pen tilt commando, basically the commando from Engineering Kit 2, but I added another servo so I can do pen tilt. And you can see there's a Pi camera there. We'll use a camera to do video streaming as in this project. The monobot here, you can see on beta test, is a special custom made. So communication scheme. So I'm running a PC, Python 3. I'm using PySerial module. For each of the robot, I have its own a separate BT-210. It's bidirectional. So I'm sending packets over to the robot, and the robot also sending packet back to the PC. And of course, they're using the UART connection on the CM550. The pen tilt commando is also using its BLE port to talk to and control a mobile device. And the Pi camera also is video streaming through Wi-Fi into the mobile device. Some programming features. So I'm using OpenCV to essentially do some graphic and display some images, and also to capture the keyboard. And you can see every time I go through the cycle, I captured up to 2 key pushes. In another video before, I talked about the Remocon packet from ROBOTIS. So you can see I'm using 2 packets, one IXD, that's what the packet that the PC will receive from the robot, each of the robot. And then TXE, of course, is the packet that from the PC we send out to each of the robots. Sometimes to one of them only, sometimes to both of them. And the PySerial module is also used, and PySerial is nice. All you have to do is just create serial 1, serial 2, and assign to the different COM port that the actual BT-210 occupy, and that was it. That's very easy. Another feature is about the virtual remote controller. The ROBOTIS remote controller, and I'm sure you have used them, it has a peculiar feature is if you release all the buttons, it will send out a 0 once. So I took some time to figure out how to do that using the key facility from OpenCV, which is hard to do sometimes. Okay, so that's provided that. You see that one. And then also I'm using toggling keys. By that I mean if I push on one, it will connect and enable and work with the pen tilt commando. So if it's off, it's a dark picture is displayed, and if it's on, the brighter picture is shown. Okay, so if I push on the button number one time, it will turn it on, shall we say. If I push the same button one again, it will turn it off, shall we say. And the toggling key, for example, so if I push 1 first and I use up, down, left, right, the PTC robot will be able to move up, down, left, right, you know. But if I leave it on and I toggle on monobot, and then both of them will be moved by the same command, up, down, left, right. And then if I turn on 3 also, and then they are controlled by up, down, left, right, also sensor data start coming in. So that's what I mean by toggling keys. I'm using tasks on the robot, a simple task program. So Remocon packet that's sent from the PC and received by robot, you can see that it's using up, down, left, right, 1, 2, 3 equivalent button. You can see each of them are parsed out separately because, and then with using the logic to figure out what's going on. Like this particular one here on Robot 2, which is a monobot. See, Robot 2 doesn't care about the button number 1 because it's not its business. So it's not a packet for it, so it doesn't care to record that data. How about the Remocon packet that's sent from the robot and received a PC? And that takes some doing. Let me explain. So I wanted to, anytime that the sender coming back, like for example, this one is Robot 2, so this is in the monobot. So I want the gyro X data from the monobot. Now this number is is a negative or positive number, and internally it uses 2 complement storage format. So it occupies all 16 bits. And if you remember, in the previous video, the Remocon packet can handle only 16-bit of the actual data. So this already used up everything, all 16 bits. So I had to send 2 packets just to send the data. But then I realized something. Usually this number is very big. If you divide by 100, it's still between minus 328 and plus 328, so we say. But still, because it's using complement, the 16-bit are all used up. But then I realized, oh, wait a minute. If I keep only the absolute value, it's a number it can handle within 8-bit storage. And then the question then is, I have to somehow put my sign bit into the 16-bit Remocon packet somehow. So what I use the highest bit, the highest among the 16-bit, I use that as a sign bit. So when there's 1 in there, it means it is a negative value. When it's 0, it's a positive value for the Gyro X Robot 2 data. And then also, I sneak in these 2 bits, and I use for them ID bits, so that the PC would know, oh, it's coming in from robot number 1 or robot number 2. So that kind of the scheme that I had to come up with to handle data coming out from the robot into the PC for sensor data. Some runtime issue. It actually we have well, and as you know, we're doing even with Bluetooth. Sometimes I lost packet, but many problem I have invalid packet. Okay, so like in here, this is the runtime display of the console on the Python. So you can see that when the data is correct, when the Remocon packet is valid, and I will process it, and you can see the yaw Z from robot 125, the gyro X from robot 20, and the robot was standing still at the beginning. So you see that's very steady, and then suddenly, boom, robot 1 invalid Remocon packet. So it happened like that. So it's always robot 1. I do not know. Maybe that particular BT-210 on it or something, but it's always robot 1, no matter what I do. Okay. So anyhow, I struggled with that, and so what I did is I found out that whenever I determined that the Remocon packet from robot 1 is invalid, I print it out, and then I found out that if I reset the input buffer, just flush it out clean again, it will pick up okay again. So that's a trick I use. Previously here you can see that this is only sending 1 key. Here you can see I'm sending 2 keys being pushed at the same time. Okay, and it was an up and the right arrow, so both of them move. Okay, and it happened to be the sensor mode. So you see the yaw start changing, yaw robot 1 start changing, and then boom, invalid Remocon packet. The gyro X on the monobot start turning, so you can see it start picking up. And then here I switched left and down. You can see the yaw start slowing down, coming back. But the gyro, you see a very sudden move because it jerked back into the other direction. Okay, so this is a quick video of how it actually used here, a quick runtime demonstration. Hello everyone, this is a quick demonstration of the Python project where I'm using controlling Bluetooth to control 2 robots, the Pen 2 Commando and the Monobot. So the pen tilt right now is set up. So using the Pi camera, it video streaming what it sees now onto my little Samsung tablet. This is the monobot. And I just started the Python software. So let's make sure everything is working. Alright, let's see. I push on 1. It's enable. I should be able to move the PTC robot now. Okay. Alright, and then I push on 2. This is a monobot. You see it's moving around both of them. That's just I want to show. Okay. And then if I push on 3 now, it starts sending data over. So you probably have to review the video to see how it's moving the data.